Hello guys, welcome back to my channel. Ensure you watch my previous videos on probability. Now, today we're on to mutually exclusive events. Now, what are mutually exclusive events? I'm not going to give you a definition. I'm going to give you an example. Let us say I have a coin and I flip that coin once. And my question to you is, what is the probability of getting a head and a tail when a coin is flipped once? Right away, you'll say to yourself, but that's not possible. Because if I flip a coin once, I'm either going to get a head or I'm going to get a tail. So the probability of head, I'm just going to use the intersection now for and tail, when a coin is flipped once, would be equal to 0. It's an impossible event. I'm either going to get a head or I'm going to get a tail. Right? In this case, these scenarios will be referred to as what we call mutually exclusive events. So what are mutually exclusive events? Mutually exclusive events are events that can't happen at the same time, any at all. So let us show that on a Venn diagram. Now let us say we have two events. Let's call them event A and event B. So this is my sample space, and we know the probability of a sample space is always equal to 1. This is event A, and then we have event B. If these two are mutually exclusive events, it means that they can't happen at the same time, which means that there's no intersection. Now, this has a lot of implications because we know that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now, based on my diagram, the probability that these two events occur at the same time would be equal to 0. There's no intersection. They can't happen at the same time. Second example, you draw a single card from a card pack, and I'm asking you, what's the probability that the card is a king and ace? We know that that is impossible because there's no ace card that is going to be a king. All right? So we know that these events are mutually exclusive. There's no way it can happen at the same time. So it means that now that the probability, so this would imply that the probability of A and B would be equal to 0. How does that affect this formula? This would mean that the probability of A or B would be equal to the probability of A plus the probability of B. Alright, so this is a formula that would come out of mutually exclusive events. Now, we cannot use this formula unless we know for a fact that these events are mutually exclusive. Here's an example of a simple question. In a race where there is no dead heats, the probability that Paul wins is 0.2. The probability that John wins is 0.3, and the probability that Mark wins is 0.4. The first part is, what is the probability that John or Mark wins? Now, it is imperative that we identify some critical terms in this question, such as there's no dead heat. What does that mean? It means that we know that in a race you can have two persons tying for first, second, or so on. But when you say that there's no dead heat, it means that there's no two person who is going to come first. All right? So there's one person who is going to come first. That is what there's no dead heat means. So here's a term that you can add to your vocabulary. Now, this is asking me, what is the probability that John or Mark wins? So right away, I know that these are mutually exclusive events. And how do I know that? Because the question tells me that there's no dead heat. No two person can come first in this particular race. So I want to know the probability that John or Mark wins. Since both of them can't win, as there is no dead heat, the probability that John or Mark wins would simply be equal to the probability that John wins plus the probability that Mark wins. All right. So before we can use the formula, we either have to be told by the question that they are mutually exclusive events, or if it's a real life question, we can read the question and use information to determine that these are mutually exclusive events. Now, the probability that John wins this race is 0.3. So I'm going to have 0.3 plus the probability that Mark wins is 0.4. So when I combine these two, I'm going to get 0.7. So this is a probability that John or Mark wins this race. Part B of this question is the probability that John or Mark or Paul wins. Once again, going back to the question, still the same question. We know that no dead heat means that no two-person can win. So all of these events would actually be considered to be mutually exclusive events, meaning the probability that John or Paul or Mark wins would be the probability that John wins or the probability that Mark wins plus the probability that Paul wins, alright? Because there's no dead heat in this race. So there's a probability that John wins plus the probability that the Mark wins plus the probability that Paul wins. Now we know the probability that John wins would actually be equal to 0.3. The probability that Mark wins is 0.4, and the probability that Paul wins is 0.2. So when I break down all of this, I'm going to end up with 0.9. Here's an example of a second question. Given that the probability of A is equal to 1/5 and the probability of B is equal to 2/3, find the probability of A or B and the probability of A and B given that A and B are mutually exclusive events. Now, once we read the question and the question itself tells us that events are mutually exclusive, we're going to write down information associated with mutual exclusion, which is the probability of A or B is equal to the probability of A plus the probability of B. Once the question tells us that the events are mutually exclusive, we can go right ahead and write down this formula because there's a 90% chance that we're going to use it. Now the probability of A here is 1/5 and the probability of B is 2/3. When I combine those, I'm going to get 13/15. So that is the probability that A or B occurs. Now what about the probability of A and B? What we need to remember here is the definition of mutually exclusive events. And these are events that cannot occur at the same time, which means that the probability of A and B will definitely be equal to 0. Alright? So it is critical that we remember this information right here.